In maintenance, we're often balancing two things: keeping equipment running smoothly and dealing with unexpected failures. But sometimes maintenance alone is not enough. A small issue can turn into a much bigger problem, and that could require a much bigger project. So how do we plan for both? So in this video, I'm going to talk about two important frameworks and how they can work together: the IPSECA process for maintenance and the Project Management Institute model for project management. By the end of this video, hopefully you'll have a better understanding of the processes to improve both your maintenance and your project planning. So let's start with the maintenance process, or the IPSECA process. I talked about this in a previous video when I talked about planning and scheduling, but as a quick recap, the IPSECA process is made up of initialization, I, planning, P, scheduling, S, execution, E, controlling, C, and analysis, A. The reason we use that is to make our processes more efficient, but we're focusing on a few key areas like routine inspections, our planned maintenance, defect identification, proactive work, lubrication, condition monitoring, all of those things that are going to hopefully keep our plant running better. So let's use a real example that I faced in a production facility when I used to work in Western Australia. And we'll start with the maintenance following the IPSECA process to assess and fix the problem. So imagine you're responsible for maintaining a production line, and it's a processing plant. During some routine condition monitoring, your team detects an unusual vibration, and it's a critical gearbox with a motor and a drive shaft and a coupling attached to them. So the first step, I, initialization. The maintenance team is going to log the defect, report it, and categorize the issue as a potential problem, potential high risk. P, planning. The planner then checks any of the historical data, work orders, decides how urgent it is, what's the criticality of it, to start putting into the plan. They review the vibration trends and decide that a laser alignment check is actually needed in the next few days, and it should be added to the next window of availability. S for scheduling. So the work is scheduled for the upcoming week in the planned maintenance because there's a shutdown coming up in 2 days. So Friday, we're going to plan it, or Thursday, even better, for Monday or Tuesday. And we know that that's going to be ahead of the failure because the vibration levels aren't that high. So it's going to have minimal impact on the production. We're going to execute it. We're going to do a laser alignment to check and find that the motor gearbox shaft is slightly misaligned. So they adjust it, recheck the vibration levels and the alignment, and confirm that the problem is resolved, or for now anyway. So controlling, C, the supervisor reviews the completed work, make sure they're happy with it, and someone updates the records in the computerized maintenance management system. A follow-up check is scheduled to monitor to see whether issue reoccurs or not. This is part of good continuous improvement and proactive maintenance. So this is a simple example of how the IPSECA process can help structure your routine maintenance and repairs. But what happens if maintenance is not enough? What happens if the problem hasn't gone away? So let's look into it and see what happens when it escalates into a project. So when maintenance isn't enough and it becomes a project, we're going to consider things like cost. If it's reoccurring repairs, it might have a cost impact. Risk. What if the temporary fix isn't suitable long term? It could lead to a bigger failure. There's a high risk. Or root cause analysis, RCA. We could find potentially that there's a deeper problem or more contributing factors than just shaft misalignment that's causing our problem. So let's go back to our example again. The same scenario. They've aligned it and the problems come back. The vibration readings are getting worse. So the team performs a root cause analysis, an RCA, and they discover through their investigations that the base plate is cracked. And this is what's causing the misalignment and causing our vibration levels to be high. No temporary repair or no alignment is going to fix this problem. It's now a project. So cost, the base plate repair is costly. It's going to have to be passed on to the project team because it's no longer a temporary fix or it's no longer a continuous operation. The risk is too high. If it fails, it's going to shut down the whole production line, and that's going to have a bigger implication than just a repair on a gearbox. The RCA findings found that there's a structural issue that also potentially has effect on other items sitting on that base plate. So we're moving from the IPSECA structured maintenance process to an example could be the PMI, the Project Management Institute's project management approach. We're shifting from repairing it to long-term solutions, short-term versus long-term. So what does the project management model look like? So instead of the IPSECA version, it's actually quite similar, and it's initiating, planning, executing, monitoring, controlling, and closeout. We might have to do feasibility study. We're going to look at budgets. We're going to have to involve the procurement side of it. We're going to have risk management. We need to involve stakeholders. We need to get approvals. We need to coordinate much more. So some different skills perhaps than what the maintenance plan will be. So back to our example, the base plate is cracked and it needs to be replaced. So we're going to look at the PMI framework, and there are others we can use, but I'm using the PMI version. Initiation. The engineering team conducts a feasibility study. Do we replace it or do we upgrade the entire system? One's cheaper, one's completely different type of solution. So we need to put a business case together, and this is what we call the charter. The project charter is developed with solutions or options and gets approved. Planning. The project manager creates a detailed project management plan, or in engineering, we often call that a project execution plan. That includes budget estimates, procurement timelines, risk assessments, allocation of resources, so time, cost, resources, and scope. We've got to look at lead times, because maybe there's a long time for this certain item to come and get delivered. Maybe it comes from overseas, which has got its own challenges. We need to schedule it during a shutdown because we can't shut down production to install it. So we've got to look at the schedule coming up. Now everything's planned, everything's ready, we can do the execution phase. The base plate's delivered, the team follows the installation plan that somebody's put together. We're going to coordinate it with maintenance, operations, maybe some quality or safety team as well. We're going to monitor and control as we go through the project, tracks progress, make sure the quality is suitable, make sure the resources are continuing to be used and tracked, make sure that it's installed correctly, make sure that it's aligned, address issues before they become a bigger problem. Then we're going to close out the last phase, the one that quite often gets missed out, close out, document any as-built drawings, any manuals, any lessons learned, formally hand over the project now back from the maintenance, or back to the maintenance, I should say, from the project team. Now it goes back to the IPSECA process and it becomes a maintenance going forward. So what started out with a simple vibration issue under a maintenance process has now been flagged and transformed into a project management model or project management process. So we can use both frameworks to work together, making sure that we're running and operating smoothly, continuous, reliable and available plant, and cost-effective decision making. So to summarize, Maintenance, and in this case, the IPSECA process, IPSECA, identifies the problem. Then we deem that it's bigger than an operational maintenance issue. We pass it over to project, and it becomes a project management problem, project management project. We use both frameworks to make sure that we're having structured decision making. That's the key thing, to manage risk and manage cost. We're always balancing cost and risk. So by applying both the IPSECA process for maintenance and a project management model for projects, we've got a structured, proactive approach for managing equipment and modifications and upgrades. Whether you're in maintenance or whether you're in project management, I think you need to understand how they work and how they work together so you can make a more informed decision to plan better, reducing risk and improving efficiency. Thanks for watching. It'd be appreciated if you could like the video and subscribe if you're not already a subscriber, and let me know what you want to see next in the upcoming videos when I'm talking about how we can use some of these frameworks to improve your processes. Thanks, and bye for now.